Hi there. In the study of differential equations, one might come across equations of the form dy dx plus 5y is equal to e to the power 2x. So it's possible in many cases just to separate the variables, put all the x's on one side and all the y's on the other side, and then integrate both sides and then get a solution. However, in this instance, one can see that you cannot integrate both the sides with respect to x on one side and y to the other side and get a definitive solution. How people have got around this issue is to multiply both sides of the equation by what is called an integrating factor. So let's just see that in action quickly. Let's multiply both sides by e to the power 5x. If I do that, I get e to the power 5x times dy dx plus 5y e to the power 5x is equal to e to the power 7x. Now, if I look at the left-hand side, it's not that obvious to see it, but let's just look at this y times e to the power 5x. Let's just say I have y e to the power 5x, and arbitrarily I wanted to see what is the derivative of that term with respect to x. So I differentiate y times e to the power 5x. What would I get? Let's see it. We just use the product rule, so we'll differentiate y with respect to x. So that's dy dx. And then keep the other constant since it's the product rule. So we have e to the power 5x. Now I differentiate e to the power 5x with respect to x. And then I get plus 5, and then keep the y constant. So we've got 5y e to the power 5x. So if I compare this to the left-hand side of my differential equation, I can see that it is the same. So this term is actually the derivative of y e to the power 5x with respect to x. So let me just substitute that in the differential equation. So d dx of y e to the power 5x is equal to e to the power 7x. Now I integrate both sides with respect to dx. Lo and behold, if I do that, on the left-hand side, I'm simply left with y times e to the power 5x. And this is equal to, if I integrate e to the power 7x, I get 1 over 7 e to the power 7x plus some kind of constant. So I can just divide both sides now by e to the power 5x. And if I do that, I get y is equal to 1 over 7 times e to the power 2x plus c times e to the minus 5x. So this is the solution. We can just take this equation of this form, multiply it by e to the power 5x, and then we see that this left-hand side is just the derivative of just one of the terms there, and then we just substitute that in because it's with respect to dx, and then integrate it, and then we get the solution. Now the question is, how did I know to multiply it by e to the power 5x? Well, that's what we're going to see now. We can do this by generalizing this example we've illustrated. So we can represent our differential equation into the form dy dx plus py is equal to q. Our integrating factor, we can define it and say that it is e to the power, the integral of p dx. So let's multiply our general form of this equation by this integrating factor. We're going to have e to this power of the integral of p dx times dy dx plus py times e to the integral of p dx is equal to q times this integral, or e to the power of this integral of p dx. So this left-hand side of this equation, okay, if we just go back up to this example, we can see that the simplification that we applied was that we had seen this left-hand side is actually equal to the derivative with respect to x of y times e to the power 5x. So we can just generalize that observation. So this left-hand side is simply the derivative of, with respect to x, of y times e to the power the integral of p dx. And this is equal to q times e to the power integral p dx. So we can integrate both sides with respect to x. And if we do that, we can see that we get y times e to the integral of p dx is equal to this integral of q times e to the power integral p dx times dx. So another way of just writing this is that we have y times this integrating factor. You can see that we had written the integrating factor as being equal to e to the power integral p dx. So we have y times the integrating factor is equal to the integral of q times this integrating factor dx. So this is our result. We can simply just apply this result if we have an equation of the form dy dx plus py is equal to q. So let's just see an example of this. If we have x times dy dx plus something like y, and this is equal to x cubed. So let's just divide everything by x to put it into this form. So we have dy dx plus y over x is equal to x squared. So in this case here, we have p is equal to 1 over x, and we have q equal to x squared. So all we have to do is just apply this result that we had just written now. So it says y times the integrating factor. So let's just write our integrating factor. Our integrating factor is e to the power integral of p dx. So this is e to the integral of p, which is 1 over x. So we have 1 over x times dx, and this is just e to the power ln x. And if you know logarithms, you'll see that this is just equal to x. So the integrating factor is just equal to x. So let's apply this result. So we have y times the integrating factor. So that's just going to be x times y. And this is equal to this integral of q, which is x squared, then times the integrating factor, which is x, and then dx. So x squared times x is just x cubed. So we'll just write that there. And then we're done. So we have xy is equal to 1 over 4 times x to the power 4 plus an integration constant. So solving for y, we just have y is equal to 1 over 4 times x cubed plus c times x to the minus 1. So this is it. All we've just done is we had an equation of this particular form, dy dx plus py is equal to q. We have seen that it's possible to have this result where we have an integrating factor and we multiply both sides and get this result, and we just apply this result, and we can see that we can very easily come up with a solution of this differential equation in this manner. Thank you for watching.